Have we found extraterrestrial life? Have you ever wondered about the existence of aliens in space? If yes, stay tuned until the end of the video as I'm going to discuss the extraterrestrial life in space. Let's dive in. First, let's define extraterrestrial life. In the context of cosmology and space exploration, it refers to the hypothetical existence of life forms originating outside of Earth. Often referred to as aliens, these life forms include a spectrum of possibilities, from microbial organisms to highly advanced intelligent civilizations. At its foundational level, extraterrestrial life could consist of microbial organisms adapted to extreme environments vastly different from Earth's. Such environments might include the frozen lakes of Europa, the subsurface oceans of Enceladus, or the methane-rich atmosphere of Saturn's moon Titan. The search for these simple life forms is driven by exploring potential habitats beyond Earth that could support biological processes. The quest for extraterrestrial life is an essential aspect of cosmology and astrobiology. It's due to curiosity about the universe and our place within it. Discovering evidence of extraterrestrial life would revolutionize our understanding of the prevalence of life in the cosmos. What are the historical perspectives about extraterrestrial life? Ancient civilizations and early philosophers entertained diverse beliefs about extraterrestrial life while reflecting their understanding of the cosmos and their place within it. Many ancient cultures, such as the Egyptians, Greeks, and Chinese, incorporated celestial beings and otherworldly realms into their cosmologies. These beliefs often anthropomorphized celestial bodies, attributing them with divine or mystical qualities. In ancient Greece, philosophers like Democritus and Epicurus speculated on the existence of other worlds and beings beyond Earth. Epicurus proposed a theory suggesting that an infinite universe could support life on other planets similar to Earth. This early speculation laid the groundwork for later discussions about the possibility of extraterrestrial life. In the Middle Ages, European scholars accepted Aristotle's theory that the Earth was the centre of the universe. This view was held until the Renaissance, when new scientific investigations started questioning these long-held beliefs. Have we found life in space yet? So, we have not found definitive evidence of extraterrestrial life. Despite extensive scientific efforts and numerous explorations, conclusive proof of life beyond Earth still needs to be discovered. Now, let's discuss some scientific revolutions. The Copernican revolution, initiated by Nicholas Copernicus in the 16th century, revolutionized humanity's understanding of the cosmos. Copernicus proposed a heliocentric solar system model, placing the Sun rather than the Earth at its center. This shift reshaped astronomical theory and prompted questions about the nature of planets and the potential for life beyond Earth. Galileo's telescopic observations in the early 17th century provided empirical evidence supporting Copernicus's heliocentric model and revealed that celestial bodies, such as the Moon and Jupiter, exhibited features. These suggested that they were worlds unto themselves. It also questioned Aristotle's idea that celestial bodies were perfect and never changed. These observations also indicated that these planets could have environments where life might exist in forms suited to the specific conditions. In the following centuries, optics, astronomy, and biological advancements further fueled speculation about extraterrestrial life. Early telescopic observations of Mars by astronomers like Giovanni Schiaparelli and Percival Lowell in the late 19th and early 20th centuries suggested the presence of channels and seasonal changes, sparking popular imagination about potential Martian civilizations. The scientific revolution, emphasizing empirical observation and mathematical analysis, laid the groundwork for the search for life beyond Earth. It challenged anthropocentric views of the universe and encouraged scientists to consider the conditions under which life could arise and thrive on other planets. Let's subscribe to the channel before moving toward the video's next part to watch more exciting updates. What are some of the controversies relating to extraterrestrial life? The Fermi paradox gives one question. If extraterrestrial life is likely to exist given the vastness of the universe, why haven't we found any conclusive evidence yet? This paradox considers the seeming contradiction between the high probability of other cosmic civilizations and the absence of clear detectable signals. Let's make some observations to determine the authenticity of this paradox. The first one is the rare Earth hypothesis. This idea suggests that Earth-like conditions necessary for complex life are exceedingly rare in the universe. Factors such as a stable star, a habitable planetary environment, and a suitable atmosphere may be uncommon, limiting the emergence of intelligent life. The second one is the Great Filter theory. This theory suggests that significant barriers prevent the development of intelligent civilizations beyond a certain point. These filters could include challenges like the emergence of life itself, the transition from simple to complex life forms, or the development of advanced technological civilizations capable of interstellar communication. The third one is the technological transcendence. Some propose that the advanced civilizations may eventually reach a stage where they can no longer rely on traditional forms of communication that are detectable to us. They might use technologies or methods beyond our current understanding, making their presence difficult to detect. Surprising, isn't it? Let's look at some of its limitations and challenges. Detecting and communicating with extraterrestrial life presents substantial technological and methodological challenges. The vast distances between stars and galaxies make direct observation and communication impractical with current technologies. Signals transmitted from even nearby star systems take years to reach us, making real-time communication impossible. Detecting signals from extraterrestrial civilizations requires sensitive equipment to distinguish artificial signals from natural cosmic phenomena. SETI initiatives use radio telescopes to scan the skies for potential signals, but these efforts are limited by funding and equipment capabilities. Physically reaching other star systems is currently beyond our technological capabilities. The immense distances and challenges of propulsion systems capable of such journeys pose formidable obstacles. Even if we detect a signal, understanding and interpreting potential messages from extraterrestrial civilizations would require overcoming cultural and linguistic barriers we cannot anticipate. Let's look at some of the potential habitats for extraterrestrial life. The search for extraterrestrial life often focuses on Earth-like planets, moons, and exoplanets that could harbour life. These celestial bodies possess characteristics that make them prime candidates for supporting life as we know it. Mars has long been a focus of the search for life due to its similarities to Earth, such as its day length and seasonal cycles. Evidence of liquid water in the past, and the presence of water ice today, suggests that Mars could have supported microbial life. Current missions, like NASA's Perseverance rover, are exploring the Martian surface for signs of ancient life and habitable environments. One of Jupiter's moons, Europa, is a promising candidate for extraterrestrial life. Beneath its icy crust lies a subsurface ocean, potentially heated by hydrothermal vents similar to Earth's, where life thrives without sunlight. Future missions, such as NASA's Europa Clipper, aim to explore this moon's icy surface and subsurface ocean to find signs of life. Note that the discovery of exoplanets has expanded the search for life. If you don't know about exoplanets, you can watch the detailed video on this topic in our channel. Simply, these planets are located in the habitable zones of their stars, where conditions are suitable for liquid water. The best examples include Proxima Centauri b and the TRAPPIST-1 system. Telescopes, such as the James Webb Space Telescope, examine the atmospheres of different parts of space for possible signs of life. Did you know that extremophiles' resilience suggests that life could exist in extreme environments on other planets and moons? For example, organisms adapted to high radiation levels might thrive on the surface of Mars. In contrast, those adapted to high pressures and low temperatures could live on the subsurface oceans of Europa or Enceladus. Now, have you considered any speculative scenarios about what would happen were you to find aliens in space? Exploring hypothetical scenarios of encountering intelligent extraterrestrial civilizations opens a realm of fascinating possibilities. One scenario involves the detection of a signal or message from an intelligent alien civilization. This contact could range from a simple hello to complex data containing information about their culture, technology, and intentions. The immediate challenge would be to interpreting the message, understanding their communication methods, and ensuring our response is clear and appropriate. Encountering a more advanced civilization could revolutionize our technology and scientific understanding. Sharing knowledge and technologies could lead to rapid advancements in medicine, energy, and space travel. However, there could also be risks if the technology is misused or if there are unintended consequences. The discovery of intelligent extraterrestrial life would have cultural and social implications. It could challenge religious and philosophical beliefs about humanity's place in the universe and spark a re-evaluation of our values and priorities. Societies worldwide might experience a period of significant upheaval as they adapt to this new reality. There are also concerns about potential threats from extraterrestrial civilizations. These might include the risk of misunderstandings leading to conflict, or the possibility that an advanced civilization could directly threaten humanity. Preparing for such scenarios would require careful consideration of defense and diplomacy strategies. Now, what are the ethical concerns involved with extraterrestrial life? Determining the moral status of extraterrestrial beings would be a complex task. Should they be afforded the same rights and considerations as humans? How do we ensure our interactions are ethical and respectful of their autonomy and well-being? Well, contact with extraterrestrial life might impact the environments of Earth and other worlds. It would be essential to consider the ecological consequences of such interactions, avoiding harm to alien ecosystems, and preventing the introduction of harmful elements to Earth. The ethics of cultural exchange would also be critical. We must ensure our influence does not inadvertently harm or disrupt extraterrestrial cultures. Conversely, we must consider how their influence might impact human cultures and traditions. There you have it, guys. Let's recall some essential points we've discussed so far. The search for extraterrestrial life encompasses a rich historical context, modern scientific efforts, and numerous challenges and speculations. Ancient civilizations and philosophers pondered the existence of life beyond Earth, with ideas evolving significantly during the scientific revolution. Speculative scenarios explore the potential implications of encountering intelligent extraterrestrial civilizations, considering the impacts on technology, culture, and possible threats. Ethical and philosophical considerations are crucial while focusing on the moral status of extraterrestrial beings, environmental impacts, cultural exchanges, and the need for legal frameworks to govern interactions. What do you think about extraterrestrial life? Let's share your thoughts in the comment section below.